When I heard that Bambu Lab was launching another big 3D printer, I assumed it would be a stripped-down version of the H2D, something like how the P1P followed the X1. But what they've released looks almost identical to the H2D from the outside. This is the H2S, a large format printer that's significantly cheaper because it ditches the complicated dual extruder for just a single hot end. So did you get your H2D too early? And is this the large format Bambu Lab printer people have been waiting for? Let's find out more. Guten Tag everybody, I'm Stefan and welcome to CNC Kitchen. This video is sponsored by Voxel PLA. Get their super reliable filaments at voxelpla.com. Their Voxel PLA and Voxel PEDG work perfectly with Bambu Lab's multi-material system and sell for only $16.99 per kilogram. Check out their full lineup at voxelpla.com. Since many of you are already familiar with Bambu Lab's first XL dual nozzle printer, the H2D, let's kick things off with a quick Q&A to answer the main questions you probably have before we dive into details. So what is the H2S? I mean, it's basically a slightly stripped down version of the H2D, with the main change being a new single nozzle extruder. That's what the S stands for. Is the build volume the same? It uses the same print sheets, but the printable area is actually a bit bigger. Thanks to the new extruder, you get 15mm more in Z height and up to 40mm more in the print width. That's more than twice the volume of the X1. But can it still do multicolor prints? Yes, it can, using the AMS, but with only a single nozzle. This creates a lot more purge waste and it is not really capable anymore of multi-material printing. Can it still laser cut and use the drag knife? Yes, it is still a hybrid printer with a mounting rail for accessories, but it will not be compatible with a 40-watt laser and can only use the 10-watt laser. But is it just a downgrade compared to the H2D? Not entirely. It does have a slightly larger print volume, and because the new print head is smaller and lighter, it can also print a bit faster. From my experience, it also prints flexibles better. So how much cheaper is it? At the time of filming this video, the combo with the AMS2 Pro is $800 cheaper than the H2D, starting at $1,499. The combo with the 10-watt laser is a $600 add-on, which makes it still $200 cheaper than the base H2D. Of course, prices can vary with import duties or special offers, so check the links in the description for the most up-to-date numbers that also help me fund my work here. So who is the H2S for? In short, anyone who wants a big Bambu Lab printer but mostly prints in a single color or with a single material. That's simple. And finally, why are some shots from my dirty basement and some from the studio? I got this machine a month ago so that I had enough time for testing, but under NDA and with a release embargo. Since I'm not alone in my studio, I did most of my prints in my basement at home and only moved it in last minute here to prevent that any information gets leaked early. With that out of the way, let's dig into details and take a closer look at the not so obvious changes. And if you appreciate this quick breakdown of the main questions, consider leaving a like. If you put the H2D and the H2S side by side, you'll hardly notice any difference, besides the name. That's in contrast to when Bambu Lab first released the budget version of the X1, the P1P, where they stripped away almost everything that wasn't strictly necessary. With the H2S, they didn't go that far. And that's a good thing, because you still get all of the same hardware and electronics, making this machine capable of printing almost any material, but you save $800 on the complex extruder most probably don't even use. The first clear difference you'll spot on the outside is that the H2S no longer has side windows, probably just a simple cost-cutting measure. Once you open the machine, both models look nearly identical, since they share the same bed size. But this is where the subtle changes start to appear. The dual-nozzle H2D was often criticized for its confusing build volume, which varied between 300 and 315mm in width, depending on which nozzle configuration you use. The H2S, on the other hand, has a fixed build volume of 340 by 320 by 340mm. That's 15 to 40mm wider than the H2D, depending on the mode, and another 15mm taller thanks to the redesigned print head. So yes, the print head is really what sets the two Bambu Lab printers apart, and it's the reason for the S in the H2S. The S stands for single, because Bambu Lab dropped the dual nozzle system from the H2D in favor of a much simpler single nozzle extruder. At first glance, the new tool head might look familiar if you have seen or owned one of the A-series printers. But under the hood, it's almost completely different. It now also uses a high torque servo motor for the extruder, which gives the printer tons of feedback data to calibrate flow, improve reliability, and even warn you about clogs or jams. The nozzle swap procedure is still the same as on the A1 and H2D. Remove the silicone sock, release a clip and tilt the hot end out, and everything in reverse to install a new one. Another positive change with the new extruder seems to be the capability of printing flexibles. It seems that the feeder gear engages very well even with very floppy materials, and printing this test 3D Benchy in 30D TPU was not a problem at all. Something I couldn't do on the H2D. The tool head also keeps the mounting rail from the bigger brother, so you can still attach accessories. Whether those are included depends on if and which combo you buy. The unit I'm testing here is just the printer with an AMS, which is why the windows are clear. If you go for the laser combo or upgrade later, you'll not only get the 10-watt laser and the drag knife, but also the green laser safety windows, which in my opinion kind of spoil the clean look. Speaking of lasers, the H2D supported both 10-watt and 40-watt modules, but the H2S only works with the 10-watt version. That's probably more about product differentiation than a real technical limitation. And if you really need a high power laser, I'd anyways recommend buying a dedicated laser cutter before spending $1,300 on the 40-watt upgrade. But back to the print head. There's another small but important difference. The H2S no longer has a nozzle camera. You couldn't actually view that camera during printing, but it was used to detect residue on the hot end and warn you early of a potential failure, and that's unfortunately missing. But the H2S still has the build chamber camera, which handles print failure detection and already saved me from a real mess several times. Either if my supports failed or if I accidentally tried to print PETG on a PLA part. Sometimes it can be a bit oversensitive, but you can tweak the sensitivity in the settings. There's also still the downward facing toolhead camera for detecting the build plate and calibrating the motion system, especially if you use the optional vision encoder plate. Aside from that, the H2S toolhead uses a lot more plastic than the more expensive H2D. Done right, that's not a problem. It actually reduces weight, which helps the head accelerate and decelerate faster, potentially improving print speed. So thanks to the lighter print head, it is faster than the dual nozzle version. Not by a huge margin, but the default printing profiles increase normal acceleration from 8,000 to 10,000 millimeters per second squared, which can shave off a few minutes on a longer, more detailed print. Its speed and acceleration always makes me smile when I stand in front of the machine and watch and especially listen to it print. First, the printer itself is pleasantly quiet, especially when you close the front door. But some of the remaining noise is just satisfying. The fast travel moves remind me a lot of the Swiss-made pick-and-place machine we have here in the studio. The H2S still uses a linear rail on X and guide rods on Y, and the sound they make without squeaking or rattling makes the machine appear simply premium. And I wonder what would happen if I put my fingers in there. Now, before we jump into the print results, this is the perfect spot to talk about today's video sponsor Voxel PLA, whose materials I used for most of the prints in this video. Voxel PLA's Pro PLA and PETG are some of the most affordable yet reliable filaments out there. They sell for just $16.99 a spool, and if you're in the US, you get free shipping on orders over $75. Their filaments are great for high-speed printing, and they've just launched a few stunning new Galaxy PETG Plus colors with a beautiful finish that also perfectly hides every last layer line. A while back, I tested their reliability by printing an 8-color version of Zelda's Majora's Mask on one of my other Bambu Lab machines. This print ran for 6 days straight, involved almost 3,000 material changes, and finished without a single issue. On top of their filaments, they also sell a variety of accessories. My personal favorite is their X filter for Bambu Lab's X and P series printers, which combines a HEPA and carbon filter to keep your workspace air clean. So if you're in the US and you're looking for a reliable filament or handy accessories for your next big project, then check out Voxel PLA at voxelpla.com. But now let's take a look at the actual prints from the H2S. Overall, they turned out very well and I have very few complaints. The few issues I encountered were entirely my fault, such as supports that were too thin or selecting the wrong filament type during setup. The 3D Banshee looks nearly perfect, with smooth surfaces, no VFAs and barely any ringing. The overhangs appear good and the top layers are perfectly extruded. The only noticeable artifacts are the shiny and matte surfaces caused by changes in print speeds. Results for my Mini-Me are very similar, and just look at that crotch. The 3D Maker Noob tolerance test printed beautifully with all the parts freely spinning down to 0.1 millimeters. The KSR FDM test looks okay, all the pins were loose and the overhangs and bridges are well done, but I noticed some cooling problems. And I even printed this with Bambu's own filament and profile to be sure I didn't mess up. The spikes printed also well initially, but eventually became quite stringy, something that I also observed on the H2D. This may be due to the longer melt zone in the hot end, which tends to ooze more. Clock Spring's Torture Toaster also printed very well, with only the 0.1mm tolerance test remaining stuck. Still, I noticed that the small 70 and 80 degree overhangs didn't look as good, especially compared to the ones I printed on the H2D. This is probably because of the less powerful fan on the new tool head that slightly compromises cooling performance. Something to keep in mind. I printed a tower over the entire print height to check for Z-wobble or any other inconsistencies, but I didn't find any. The highlight was definitely the Master Chief helmet, which took nearly 2 days to print and used about a kilogram of material with substantial support. But the final result was incredible and really demonstrates what this machine can do and is good for. I scaled it down to 80%, but it still fits my head. Still, keep in mind, larger machines tend to have bigger power consumption because of the bigger heated bed. I printed the 3D Banshee and the H2S used over 60% more energy than the same print on the X1. The multicolor highlight was the Earthworm Jim figurine by Waxter, printed in 5 colors with an AMS2 Pro and the AMS HT. The print took 37 hours and generated a lot of waste, but the final result looks fantastic. The same applies to the dual color articulated Panda. Most of these prints were done in PLA, but I also ran PETG and even ASA parts for my Positron V3 build, and they all came out great with no warping, also thanks to the heated chamber at a flawless quality. In terms of reliability, I've already logged over 200 hours of printing on the H2S and combined around 1000 hours on my 2 H2Ds here in the studio. Even though the performance of the H2D doesn't tell us anything about the reliability of the new toolhead on the H2S, due to the same motion system and electronics, it still tells me a lot about the overall reliability of the H series. And they have certainly been the fire and forget machines you expect at the price point from Bambu Lab. One of the H2Ds has, for example, done serial production of Robin's Pixel Pump with no issues at all. I've been throwing tons of different materials and tasks at the machines, and most errors were honestly user related. But there still are a few minor things that annoy me. First of all, the sheer size and weight of the machine makes it a pain to move around. But honestly, that's something you have to expect when you buy such a large printer with a sturdy frame. The bigger issue for me is filament feeding from the back. Using the AMS, it is super convenient, and even the side spool holder works great for rolls that don't fit the AMS thanks to the Bowden tube that routes to the back. But when you're printing with flexibles or very stiff and brittle materials, you are supposed to feed them directly into the back without any bends. With TPU, you even have to remove the Bowden tubes from the buffer and push the PTFE directly through a hole in the back of the printer. On my desk setup, this is not too bad, but once the machine is against the wall, feeding filament this way becomes really awkward unless you physically turn the printer, which isn't easy because of the rubber feet and the weight. Another thing that's not perfect is the heated bed. There's still an around 10-degree difference between the center and the corners that can cause worse bed adhesion at the extremities. To their credit, at least they fixed the temperature readings, so when you set 100 degrees Celsius, you now actually get 100 degrees Celsius at the bed. That wasn't the case on the early H2Ds. And finally, something I'd straight up call false advertising. Bambu Lab claims that when printing low temperature materials, the exhaust air is filtered through the HEPA and carbon filter. But on both of my H2Ds and also on the H2S, that's simply not happening. The PLA and PETG fumes are just blown straight out of the bag. I asked Bambu about this and they told me it's planned to be implemented later this year, but for now, it's just not working. I could go on and list every single detail from my H2D review, but honestly, almost everything else is identical between the H2D and the H2S. It still reaches 350 degrees Celsius on the nozzle, 120 degrees Celsius on the bed, and has an actively heated chamber that can get up to 65 degrees Celsius, making it suitable for a wide range of technical materials. If you want a deep dive into how the AMS, the laser, or the cutter work, check out the videos I've linked in the description. So here's the real question you need to ask yourself if you're torn between the H2D and the H2S. Do you actually need proper multi-material printing? Because the H2S isn't really designed for that. Instead, it feels more like a second generation XL version of the X1, even if it's more than that. The dual nozzle printhead on the H2D is powerful but over-engineered in a way, which drove up both the price and the complexity, and it was more than most Bambu users really wanted. If all they needed was a larger printer. I think the $800 lower price of the H2S finally makes this machine appealing to a broad audience that wanted this form factor, but the H2D was just too expensive. If you were not a fan of Bambu Lab's policies and their fairly closed ecosystem, the H2S isn't going to change your mind. There are alternatives out there with similar features that run on open source firmware and let you use the slicer of your choice. That is just not what Bambu Lab is, and it's not what they're aiming to become, in my opinion. They're following the path of Apple, controlling the ecosystem so that everything works together as conveniently as possible for the user. For example, I couldn't hand my mom my Voron 3D printer, explain Thingiverse, Orca Slicer, Clipper, and how to swap materials, and expect her to succeed. But I could give her Bambu Handy on her phone, show her how to pick a model from MakerWorld, and she'd have it printing at the push of a button, especially with how easy the AMS makes material changes. I think Bambu Lab does one of the best jobs in the industry right now, at the cost of some freedom. Another thing I appreciate is that they don't pump out dozens of printers only to abandon most of them months later. Just look at my pre-Kickstarter X1 Carbon. It still prints beautifully, recently got the latest user interface through the regular firmware updates, and now supports all of the new AMS units. That level of long-term support is rare, and only Prusa comes to my mind that still gives you firmware updates even 7 years later. For me, if I just want to print something, meaning I want to use the printer as a tool, I'm perfectly fine with staying in the Bambu Lab ecosystem. I still can use my own materials, and the slicer has all the features that I usually need, and the machine is reliable and just works. I can even be hiking in the mountains and check the status of my prints in real time. But if I want to experiment with bleeding edge software features or tweak every little detail of the firmware, I'll grab a more open machine. But in this case though, the printer itself becomes the project, not just a tool. So here's the bottom line. If you want a fully open 3D printer where you can control every aspect and your data, don't buy the H2S or any Bambu Lab printer for that matter. But if you are after a reliable tool that just works no matter what material or model you throw at it, Bambu Lab's machines are among the best on the market. And the H2S continues that and finally gives you that large build volume. Without all the extra features, you probably won't use 90% of the time anyways. But that's just my take. What do you think? Let me know down in the comments. So if you have decided that you want to get a big Bambu Lab printer, which one should you get? The H2S or the H2D? In my opinion, it really comes down to your use case. If you mostly print single material, single color parts, and just need the large print volume, the H2S is a fantastic choice. And if you're wondering whether you need an AMS or not, let me be totally honest here. I love the AMS, but 95% of the time I use it purely for convenience. It means I always have 4 materials or colors ready to go without swapping spools, and the AMS Pro also doubles as a dryer. I very rarely use it for true multicolor prints. Whether that's worth the extra money is up to you, but personally, I wouldn't want to be without it. So when does the H2D make more sense? I mean, if you frequently want to do real multi-material printing, like mixing flexible and rigid materials, using a dedicated support filament, or if you're regularly doing multicolor work, that's where the dual nozzle toolhead really shines. It cuts down purge waste dramatically and makes certain prints possible that simply aren't practical on a single nozzle system. The 40-watt laser could also be a reason to go with the H2D, but you've already heard my opinion on that. So to sum it up, if you want a large format Bambu Lab printer, the choice is simple. Do you need dual nozzles or not? Answer that and you'll exactly know which one to get. If I was able to help you in your purchasing decision, I'd highly appreciate it if you use the link down in the description. Using these affiliate links doesn't cost you anything, but they help me keep the lights on here in the studio. So thank you for that. Thanks for watching, everyone. I hope you found this video interesting. If you want to support my work, head over to Patreon or become a YouTube member. Also check out the other videos in my library. I hope to see you in the next one. Auf Wiedersehen and goodbye.